Traditional software is built for the binary world of zeros and ones, but plasma, with its constantly shifting particles and electromagnetic fields, doesn't quite fit into neat little boxes. The software needs to be able to interpret and respond to these fluctuations in real time, which is no easy feat. One misplaced line of code could be the difference between a successful calculation and a complete meltdown. It requires a whole new way of thinking about programming, and it's an area where even the slightest error can have explosive results.
Chapter 4. Energy Consumption, a Power-Hungry Beast. Generating and controlling plasma takes a ton of energy. We're talking about levels of power consumption that would make even the thirstiest gaming PC blush. Some might argue that the potential benefits of plasma computing, like faster processing speeds and more efficient AI, outweigh the energy costs. But the reality is, we haven't even reached the point where we can fully harness those benefits yet. Until we can find a way to make plasma computing more energy efficient, it's going to be tough to justify its widespread adoption. The potential is there, but the practicality just isn't.
Chapter 5. Safety Concerns. Proceed with caution. When you're dealing with something as powerful and unpredictable as plasma, you better believe there are some risks involved. First off, there's the obvious danger of extreme heat. Any malfunction or containment breach could lead to a less than ideal situation. Plasma emits all sorts of funky particles that you don't want anywhere near your DNA. Researchers have to take extreme precautions to shield themselves and their equipment from harmful radiation exposure. Plasma generates strong electromagnetic fields that can mess with electronics, communication systems, and even medical devices. Safety is a major concern with plasma computing, and it's one of the reasons why this technology is still largely confined to research labs.
That's it for today's deep dive into AI's plasma computing fails. We've covered a lot of ground, from plasma instability to hardware limitations, software bugs, energy consumption, and safety concerns. It's clear that there are still some major hurdles to overcome before plasma computing becomes mainstream. But hey, that's the nature of cutting-edge tech, right? It's all about pushing boundaries, learning from mistakes, and constantly innovating. If you enjoyed this video, make sure to like, subscribe, and hit the bell icon for more tech insights. And be sure to leave a comment below on what tech topic you'd like us to cover next. Until then, keep exploring, keep questioning, and keep pushing the limits of what's possible. Peace out. Peace.